questions 11 through 20 on the 2021 grade 10 AMC 10A. For which of the following integers is the base b number 2021b minus 221b not divisible by 3? Let's expand 2021b minus 2021b minus 221b. So it would be 2 times, remember it's base b now, so b third plus 0 times b squared plus 2 times b to the power of 1 plus 1 times b to the power of 0. And then we're subtracting this, and that's going to be 2 times b squared minus 2 times b to the power of 1 minus 1 times b to the power of 0. So this is 2b cubed plus 2b plus 1. And that is going to be subtracted by 2b squared minus 2b minus 1. Okay, let's see here. The 1's cancel, and so do the 2b's. So the only thing we're left with is 2b to the power of 3 minus 2b squared. I can factor out a 2b squared, and all I'm left with, therefore, is b minus 1. Okay, that's pretty good. Let's work through the answer choices. If I put 3, well, obviously it'll be divisible by 3, because the 3 will go right there. If I put 4, this becomes a 3, therefore divisible by 3. If I put 6, well, 6 goes here, and 6 is divisible by 3. If I put 7, 7 minus 1 is 6. 6 is divisible by 3. If I put 8, 8 goes here, this becomes 7, and neither of those are divisible by 3. So the answer to number 11 is E. Two right circular cones with vertices facing down, as shown in the figure below, contain the same amount of liquid. The radii of the tops of the liquid surfaces are 3 and 6. Into each cone is dropped a spherical marble of radius 1, which sinks to the bottom and is completely submerged without spilling any liquid. What is the ratio of the rise of the liquid level in the narrow cone to the rise of the liquid level in the wide cone? They're saying the volumes are equal. So I'll just say this is 1 and this is 2. So the volume for 1 is equal to the volume for 2. So how do you figure out the volume of a cone? It's 1/3 times pi r squared times height. And we'll just call this 1 and 1 like that. And this would be 1/3 pi r squared height. We'll just call it 2 and 2. So the 1/3s and the pi's cancel. So we can just put in the radii, which is 3 squared h1, and then this is 6 squared h2. So this is 9h1 is equal to 36h2, and therefore h1 is equal to 4h2. So that's very important that we got that. Now let's talk about that marble. That's a sphere. So how do you figure out the volume of a sphere? Volume of a sphere is 4/3 pi r cubed. And in this case, the radius is 1. So that's just going to be 4/3 pi, since 1 cubed is 1. So we are basically taking that 1/3 pi r squared h1, and we're adding to it this amount. And in the end, we're getting a ratio. So let's just give some values for h's. I'll let h2 equal 3, and therefore h1 can equal 12. It doesn't really matter. As long as we abide by those rules, we should be fine. So that means this plus that sphere, which is 1/3 pi r1 squared h1 plus 4/3 pi, is equal to the new equation would be 1/3 pi r, I'll just say put n for new, squared, and the new height, right? Because when you put in a pebble or sphere, the height will rise a little bit. And that's pretty much what they want you to figure out. Okay, so as before, the 1/3 and the pi's cancel. So all you're left with is, so this cancels, and the pi, this cancels, and this cancels out. So all you're left with is r1 squared h. r1 is 3, so 9. and then h1 I've called 12 plus 4 is equal to rn squared hn. And this looks like 9 times 12 is 108, 108 plus 4 is 112. So there we go. And you do pretty much the exact same thing for this scenario. So now you'd be taking that and you'd be adding the sphere, that pebble. So r2 squared h2 plus that sphere, 4/3 pi, and that is equal to 1/3 pi. I'll just call it big R, and that's nu squared hn. So this is the same story here, and when you plug in the value, the pi over 3's cancel from everywhere, and then r in this case is 6, so that becomes 36, and then h2 I had given a value of 3. So 36 times 3, that is 108. 108 plus 4 is again 112. So 112 equals rn squared hn. Okay, so now we're ready to compare this, and that should give us the answer. So if I put the rn squared hn over the big Rn squared hn, that is 112 over 112, which is just 1. And then the ratio of the radii is basically just 1 to 2. With similar triangles, no matter what it is, it's always going to be a 1 to 2 ratio. So Rn over Rn squared is basically 1 over 2 squared, like that. And then you'll get hn over hn like this, and that's 1. So isolating for hn over big Hn is going to be 1 times 4, which is just 4. And there you go. So 4 to 1 would be the ratio of the two heights after the sphere, pebble, marble, whatever, is dropped inside. So number 12, the answer is E. What is the volume of a tetrahedron ABCD with edge lengths AB is equal to 2, AC is 3, AD is 4, BC is root 13, BD is 2 root 5, and CD is 5? Well, let's draw one, and let's see what we get. So let's just draw a tetrahedron. So here we go. And let's see if we can make this match. If we can get a bunch of right angles, that would make our life a lot easier. So let's see what we get. Let's see if that's a right angle. Well, I have to label it first. Well, I'll call this A, actually. I think it'll help. This A and this B, this C and this D. Okay, so AB is 2 and AC is 3. So that means BC is root 13, and I think that works as a Pythagorean relationship. 2 squared plus 3 squared is at root 13 squared. This is 4 plus 9, and this is 13. Yes, it does. Okay, so that proves that is a right angle. Okay, great. Now, let's see if we can do the same thing. AD is 4. Well, this is 3 and this is 4, so that's a 3, 4, 5. That's a very famous Pythagorean triple. That one I know for sure. So that means this is a right angle, this big angle I drew there. And then let's see if the other one works out. They're saying BD is what, 2 root 5? So let's see if 2 squared plus 4 squared is equal to 2 root 5 squared. 4 plus 16, that's 20. 4 times 5 is 20. So yeah, so that means this is a right angle also. So those are all right angles. So all I have to do now to figure out the volume of the tetrahedron is as follows. Since it is indeed a tetrahedron and we've got a whole bunch of right angles, 1/3 times the area of the base times the height. So 1/3, what is the base? Well, the base is this triangle, so it's 1/2 base times height. 1/2 base, I'll use 3 as the base and 2 as the height. And then the height of the tetrahedron looks like that's 4. So 4. This would be 1/3. Okay, so that looks like it just reduces to 4. That's it. Number 13, the answer is C. All the roots of the polynomial are positive integers, possibly repeated. What is the value of b? Well, by Vieta's, the sum of the roots, and in this case, since it's z to the power of 6, there will be 6 roots, is minus b over a. And in this case, that would be minus 10 over 1. So that's 10. So the sum of the roots is 10. And then the product of the roots by Vieta's is z over a. And in this case, that's 16 over 1, which is 16. So I've got 6 numbers, 1, 2, 3, 4, 5, 6. And when I add them, they equal 10. But when I multiply them all together, they equal 16. So after a little bit of thought, you realize that that's most likely going to be 2, 2, 2, 2, 1, and 1, right? Because if you add these numbers, the total will be 10. And if you multiply them all, the product will be 16. So really, it's just a question of inspection. But now I have to figure out the coefficient b, which is the coefficient of z to the power of 3. Okay, so all I really have to do is put this in Fermat. You can use z's, I guess. If they're using z's, we'll use z's. So it's z minus 2 to the power of 4, since it's 4 times, and then z minus 1 to the power of 2. Now we have the nobody's favorite task of expanding this, but I won't expand it entirely. I'll just do a little bit. So z squared minus 4z plus 4, and then it would be again another z squared minus 4z plus 4, and then the z minus 1 is just z squared minus 2z plus 1, and I'll do that one too. So it'll be z to the power of 4 minus 8z cubed plus 24z squared minus 32z plus 16. And at this point, you don't really need to expand anymore, because we just really want the coefficient of z to the power of 3. What's going to be in front? Okay, well, when I multiply this by these guys, I get something that's more than z to the power of 3. When I multiply this by just the 1, I'll get a coefficient of z to the power of 3, and that will be negative 8. This will give me a z to the power of 3 if I multiply it by this. So that's going to be 24 times minus 2, which is minus 48. And then this multiplied by this would give me a coefficient of z to the power of 3, and that would be minus 32. And then this one won't give me a z to the power of 3. So that's the coefficient. So that looks like minus 8, minus 48, minus 32. What's that? Minus 88? Minus 88 is the coefficient in front of z to the power of 3. So therefore, b is minus 88. And that means number 14, the answer is A. Values for A, B, C, D are to be selected from 1 through 6 without replacement. How many ways are there to make such choices so that the two curves y is equal to ax squared plus b and y is equal to cx squared plus d intersect? Well, just a little bit of a review. If you have a graph and you have the basic y is equal to x squared, it would look like this. If we are adding some coefficient that's positive, right, 1 through 6, it will move it up like that, where this is 3. Now I want to talk about the coefficient in front of the x squared. If it's just 1, it has sort of that kind of a shape. But what if you increase it? What if you make it 5? What does it look like? Does it get wider or does it get narrower? Well, it gets narrower like this. So for example, if it was y is equal to 1 million x squared, when x is 1, y would be 1 million. So y would be way up here. So that's how you can kind of easily figure it out. Do extreme case scenarios. So the only way these two will ever intersect is a following situation. One is like this, and the other one below it is like that, meaning that the one below has to have a coefficient before x squared greater than the coefficient before x squared there. So for example, let's say the bottom one is y is equal to cx squared plus d. And the top one is y is equal to ax squared plus b. The only way they were going to intersect is if that c has to be greater than that a. And obviously from the graph, b is greater than d, because b is higher than d. So these are basically the two conditions that we have to meet. So we have six numbers. So first I'm going to say, let's tackle this one. So from these 6 numbers, I will choose 2. So 6, choose 2. And I will assign one number to be the c, and one number, the smaller number, to be the a. That way c will be greater than a. And 6, choose 2, the value of that is 15. Then I have to multiply by, because I have to do this also, and this and that. That's why you multiply. Well, I've already chosen 2, so there's 4 numbers left. From those 4 numbers, I have to choose another 2. And I have to assign those to b and d in a way so that b is greater than d. So whichever one is the smaller one will become d. Whichever one is the greater one will become c. 4 choose 2 is 4 times 3 divided by 2, which is 6. So that's it, 15 times 6. And that is 90. Number 15, the answer is c. In the following list of numbers, the integer n appears n times in the list for n between 1 and 200 inclusive. What is the median of the numbers in this list? Let's start off with a very simple example. Let's say there's 4 numbers, and I said, what's the median? Well, you take the second number and the third number and add them and divide by 2. It would be the average of those 2 middle numbers. But we don't have 4. We have, I don't even know how much we have. We have a lot. The first I have to do is figure out what is the total number. Well, the total number of terms in this list, I guess, would be 1, then 2, plus 3 of those 3s, plus 4 of those 4s, and then ... You get the idea. Eventually, you're going to have 200 2s, 200 200s. That's what I meant to say. So this is the number of terms in the list. Well, you know that formula for consecutive numbers. So that's the formula I will use. Divide that by 2, and when you do this math, you get 20100. So this is how many terms there are in that entire list. So the median, very similar, would be the average of the middle 2. Well, the middle 2 would be as follows, ... If you kept going, the middle 2 would be this one and this one, which would be half of this, would be this one here, which would be 10050, 10050. And then this guy would be the next one, the 10051 term. So if I can find these 2 terms, I'll add them, take the average, and I've got the median of the list. Okay, so how do I do that? Well, we have to figure out what number comes here and what number comes here. Well, I don't really know that, but I know that I can try to get close to that number. So 1 plus 2 plus 3 plus ... all the way up to some number n will perhaps be close to that. I mean, I don't know if it'll be exact, but it'll be close. So let's see. The sum of this, of course, is n times n plus 1 over 2. And I want that to be sufficiently close to 10050. It'll give me some sort of an idea of what the number will be. Okay, so let's work with this. N times n plus 1, cross multiply, and that's going to be 2010. Now I don't have to, use a quadratic. This is just an estimate, right? So this is like really very similar to n times n is equal to 20100. So it's kind of like n squared, right? So take the square root. Take the square root of this number. And when you do, you get approximately 141. So I'm confident that either sufficiently close to here, there'll be 141, a whole bunch of 141. So let's see what we get. 141 times 142 divided by 2, right? I'm trying to figure out what are the number of terms all the way up until 141. That's the formula that you'd use right there. And when you do this math, you get 10,011. So when we get to that term, that's the last 141. The next term after that would be 142. So these would be 142, 142. So after this, you would have 142 142s. So there we go. I just have to take the average of these two. Well, obviously, the average of those two will be 142. So number 16, the answer is C. Trapezoid ABCD has AB parallel to CD, BC is equal to CD is equal to 43. AD is perpendicular to BD. O represent the intersection of the diagonals AC and BD, and let P be the midpoint of BD. OP is 11. The length AD can be written in the form m square root of n. What is m plus n? Well, our first task is to try to figure out what this looks like. So first I have to draw it in a way so that this becomes a right angle. And I think that is pretty decent. That's a pretty decent right angle. And then I've got to draw an isosceles triangle here. So, and that's got to be parallel. So I think that's good enough. Not perfect, but that's good enough. So this is isosceles. That's a right angle. And let's label this now. So A, B, C, D, and then AB is parallel to CD. Okay. BC is equal to CD, and then both of those are 43. And then AD is perpendicular to BD. Okay, perfect. So I got it all. And then what are they saying here? O is the intersection of AC and BD. AC and BD. Okay, I got to draw another line. AC to BD. That intersection they're calling O. So this is O here. And then P is the midpoint of BD. Okay, so midpoint approximately here. So that's P. And OP is 11, so that distance is 11. All right, and then we have to figure out AD. So find AD. And that is equal to m root n. And then in the end, we have to figure out m plus n. Okay, so I very much think there's a lot of similar triangles in this one. That just screams similar triangles. Because as soon as I saw parallel, that means they're going to use that Z pattern and all that stuff. Okay, so the first thing I'm going to do is draw a line from C to P. And that's going to be a perpendicular line. And that, because it's isosceles, chops BD in half. So for example, if the distance from there to there is, say, x, then that means this distance would be 11 plus x. It's got to be the same. All right. Okay, so from similar triangles, the first similar triangle is I see is that BPC is going to have the same angles as BDA, triangle BDA. Triangle BDA. Yeah, because both of those have 90, and both of those would have a theta, because it's isosceles. So if this is theta, then this is theta also, right? Those two angles have to be the same. So both of those triangles would have a 90 and a theta, and then of course the third angle would be 90 minus theta, so they have all three angles the same. All right, so from that, BP over BC would be equivalent to BD over AB. So that means in my, in terms of my labeling, x plus 11 over 43 would be the same as 2 times x plus 11 over over AB, sorry. So cross multiply, and it looks like the x plus 11's cancel, so AB just equals 86. Okay, well, that was pretty quick. All right, so I think we have one more similar triangle relationship to look at, and that's ABO is similar to triangle CDO. Because of opposite angles, this angle will be the same as that angle, and then they already share a theta, and then the third angle would be whatever. They would be the same pretty much. So from this relationship, we get DC over OD is equal to AB over BO. So that would mean 43, DC is 43, OD is X, AB I just got was 86, and then BO is X plus 22. So we've got to do a little bit of math here. Cross multiply and you get 86X is equal to 43X plus 43 times 22. So that means 43X is 43 times 22, and therefore X has got to be 22. So dB I can figure out next. dB obviously would be 2x plus 22, and therefore when you substitute x equals 22, that just becomes 66. All right, the final step, I guess, would be to figure out AD, and I think I can do that using Pythagoras pretty quickly. AD squared plus DB squared is equal to AB squared. So AD squared will be AB squared, which is 86 squared, minus DB squared, which is minus 66 squared. So AD squared would be 3040, and therefore when you take the square root and do the necessary math, it'll be 4 root 190. So finally, m plus n, well, this is in the form m root n, so my m is 4, my n is 190, and therefore m plus n is 194. Number 17 would be D. Let f be a function defined on the set of positive rational numbers with the property that f at a times b is equal to f at a plus f at b for all positive rational numbers a, b. Furthermore, suppose that f also has the property that f at p is equal to p for every prime number p, for which of the following numbers is f at x less than 0. We have to go through the answer choices, and I'm going to go through I'll go through all of them. Why not? So let's start with 17 over 32. F at 17, since f is a prime, 17 is a prime number, that's just going to be 17 according to their definition. 32, however, is not a prime number, but we can break it up using that. We can break it up using 2 and 16. Well, 2 is a prime, so that just becomes 2. F at 16 is not a prime. Well, 16 is not a prime, that's what I meant to say. But that can be broken up into f at 2 plus f at 8. So we have 2, again, 2 here, and then f at 8 can be broken up into f at 2 plus f at 4. And then this is, again, a whole bunch of 2's, and this one can be broken up into f at 4 times f at 2 times f at 2. So that looks like 5 2's, that's equal to 10. So that means this 17 over 32 is really just 17 over, and that's obviously greater than 1. We want something eventually that's less than 1. Okay, and in particular, it was f at that. We just broke it up into f at 17 plus f at, or rather divided by f at 32. All right, so we got to do the same thing for all these other ones. So f at 11 over 16, so that's going to be f at 11 over f at 16. So f at 11, that's just prime, that's 11. F at 16, using the same technique, we actually did that here, right here, and that's just going to be 8. So again, this is greater than 1. Okay, so that's gone, that's gone. How about the next one? 7 over 9, f at 7 over f at 9. F at 7 is just 7 because that's prime. F at 9 is f at 3 plus f at 3. Since those are prime, you have 7 over 3 plus 3. 7 over 6, which is greater than 1. That's gone. Okay, eventually we're going to get it. F at 7 over f at 6. So that's 7. And this looks like f at 2 plus f at 3. And that's 7 plus over 2 plus 3, which is obviously f7 over 5, which is greater than 1. Okay, by process of elimination, the answer's got to be E, but let's just do E and see why that is indeed less than 1. F at 25 over f at 11. Well, f at 25 is f at 5 plus f at 5. F at 11 is just 11 because that's a prime. And f at 5 is a 5 because 5 is a prime. So we have 5 plus 5 over 11, which is 10 over 11. And finally, that's less than 1. So number 18, the answer is E. The area of the region bounded by the graph x squared plus y squared is equal to 3 times the absolute value of x minus y plus 3 times the absolute value of x plus y is m plus n pi, where m and n are integers. What is m plus n? Well, we have 4 scenarios, and let's talk about all 4. So you will get the hang of this after a while. The first one is, of course, where x minus y is greater than or equal to 0, and x plus y is also greater than or equal to 0. So that just means that the equation just becomes x squared plus y squared is equal to 3x minus y plus 3x plus y. When you expand and collect like terms, you get x squared minus 6x plus y squared is equal to 0. And then if you complete the square, you take half of this and square it. And then, of course, you have to subtract that. You get this, and then it beautifully factors into just x minus 3 squared plus y squared, and then you put the 9 on the other side. So this is a circle, and it's a circle with the center 3, 0, and a radius of 3. So something like that. And this is the center at 3. So that's basically what you're going to do. The next scenario is very similar. It's this time x minus y, but it's less than 0. X plus y is still greater than 0. And then I'll just write the other scenarios. The other one would be both of them being negative. X minus y less than 0. X plus y less than 0. And then the third scenario, x plus y less than 0, but x minus y greater than 0. And for each one, you would do the similar kind of calculation. Okay, so let's do the second one. X minus y is less than 0, and x plus y is greater than 0. So again, x squared plus y squared, but this time it would be 3 times negative x minus y, like that. And then, of course, the other guy doesn't need to be changed since it's greater than 0. So again, I'll let you do the algebra. You expand, collect like terms, and when you do, you get x squared plus y squared minus 6y is equal to 0. Again, you complete the square. Take half of that and square it. Half of minus 6 is negative 3. Square it, you get 9. And then immediately subtract that 9. That allows you to factor those 3 terms. You get y minus 3 squared, and then the 9 put on the other side. That is also a circle. This time 0, 3 as the center. Radius is 3. So something like that, I guess. And you get the hang of this, so I'll let you do the last 2 since they're very similar. The next one, x squared plus y squared. Well, I'll just do it, I guess. Since it's greater than 0, that one doesn't change. But the other one, you have to put a negative in front of it, like that. All right, so when you collect like terms and expand and do all that stuff, since you're an expert, I'll just write the final version. It becomes this. That is a circle again. This time the center is 0 for x minus 3 for y. And I think that's going to be down here. So something like this. And then last one, they're both negative, so it would be x squared plus y squared is equal to 3 negative x minus y plus 3 negative x plus y. And this one, if you collect like terms and all that stuff, you get x plus 3 squared plus y squared is equal to 9. And that is a circle, this time with center negative 3, 0. So it will be something like this. And all those circles should be equal. So that's pretty good. All right, so I got to find the area of this whole thing. All of this whole shape. So obviously it's 4 circles, but there's a lot of overlap in there. So there's a couple ways of doing that. I think the easiest is just to make it a square, meaning just connect those and that makes it a square, as you can see. And then I just have 4 semicircles. Easiest way of doing it. So the square, what's the length here? From here to here is 3, so that's going to be 6. So the square is just 6 squared, so that's 36. And then the 4 semicircles, so 4 times pi r squared divided by 2. 4 semicircles, right? So that's just going to be 2 pi r squared. R is 3, so 2 pi times 3 squared would be 9, so that's 18 pi. So the total would be this 36 plus 18 pi. And that, they are saying, is m plus n pi. So therefore, m plus n, my m is 36, my n is 18, and that is 54. Therefore, number 19, the answer is E. In how many ways can the sequence 1, 2, 3, 4, 5 be rearranged so that no 3 consecutive terms are increasing and no 3 consecutive terms are decreasing? So I'll give you one such example. 2, 1, 3, 4, 5, 1, 3, 2. So as you can see, there's no 3 terms that are increasing and no 3 terms that are decreasing. So basically, I was kind of looking at it like a down, up, down type of scenario where you've got to keep alternating. You can't go up, 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 down, 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 right? Because that would be against the rules. So whatever terminology you want to use, I like the down, up, up. So there's only really 2 ways of making such a number. It could be either down, and then go up, and then down, and then up, and then down again. Or you can start by going up, but then come down, and then up, and then down, and then up. So let's talk about these. Now, because of the symmetry, the good news is you save a little bit of time. Whatever answer you get here, whatever number, this will be the same number. And then we can just add those 2 and then circle the right answer and move on. So the first scenario, of course, is we got 5 numbers. So 1, 2, 3, 4, 5. And we've got 2 ups, right? So one of those ups has to be a 5. The 5 cannot be a down. You can never go down to 5 from the list 1, 2, 3, 4, 5. Okay, I think that much pretty much makes sense, but still we got other numbers to figure out. The other choice, I think, for the other up, I should say, is if we put one of the bigger numbers, so 4 or 3. And I think that's the only way, because if I put a 2, it's not going to be able to work. So I think this is pretty much the strategy. And then the 5 can also go here or here. The 4 can go here, 3 can go here. So this is sort of a building blocks. And then the other 3 numbers, which obviously we would put in the down position. So let's start with the first one, the one with the 4 and the 5. I have to place a 1, 2, 3, right? So let's see if I put 1, 2, 3 like that. Does it work? Yeah, it works. So the 1, 2, 3s can be placed anywhere. So there's 6 permutations of 1, 2, 3, right? Either 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So any of those 6 permutations can be placed in these 3 positions. So we got 6 possible ways of creating that number. The next one with the 3 and the 5. What are the numbers remaining? A 1, a 4, and a 2, right? A 1, 2, 4. Okay, so this was a down, down, down. So this number's got to be less than 3. This number's got to be less than 3. This number's got to be less than 4. So this number has to be a 2 or a 1. And this number is going to be either a 1 or a 2. So the 4 has to go there. So that means the 4 is fixed here, but I've got 2 choices here. And then whatever number goes here, the remaining number would go here. So it looks like I've got 1 choice here, 2 choices here, but then 1 choice here since there'll be only 1 number left. So 1 times 2 times 1, that's 2. Okay. And by the same story, this is going to be 6, exact same conversation as this guy up here. And this will be 2 for the exact same reasoning as this up here. So that gives me 6 plus 2 plus 6 plus 2, which is 16. So this is 16. And as I promised, this would be also 16. And you can go through that. It's the same sort of story. So the total, 16 and 16, is 32. And therefore, number 20, the answer is D.